Hello all, welcome to our game DX Ball in FPGA. What we really tried to do here is to develop a DX Ball game using field programmable gate array. Our project features one person can play the game at a time. Score is shown using two 7-segment displays. Code is written in Verilog. Multicolor display makes it attractive, and the player gets as many chances as he wants. Now let us look at our project details. The components required for running our project is an Altera UP education kit, one PC set, one additional monitor, and a parallel port programming cable. Now let us take a glimpse at our game. You can see in the screen there is a colored brick wall at the top of the screen. There is a ball and a bat. The player can move the bat right or the left direction. The ball is reflected if it hits the right or left wall. When the ball hits a brick wall, the upper adjacent brick disappears. In case of no brick there, the ball just gets reflected. At the bottom, if the ball hits the bat controlled by the player, it's reflected, otherwise the ball is vanished and the player pays a forfeit. Before going in, let us see how an FPGA is used. Using the mother PC, the entire code is written in Verilog. After successful compilation, the program is then downloaded to FPGA board. The output is then sent through a VGA cable to a monitor. The two switches on the board is used as start and restart. The other two are used as right and left move switch. The output is shown in two 7-segment displays displaying on the FPGA board. In short, this is the block diagram. There is the mother PC, the code is sent to FPGA board, the game is played there, and the output is shown in the VGA display. So we can look at how we did it. This is the UP2 kit that we used to make our game. The output device is divided into 64 into 60 superpixels. The ball is just a superpixel program to move. The bat is controlled by two switches, PS1 and PS2. Bits of different colors are introduced to make the game attractive and different sizes to make it more challenging. Once the program is downloaded into the FPGA board, it can run without the help of the mother PC, where the code is written. Now let us take a look at the real-time display of our game. We can see the colored bricks at the top and the bat and ball moving. Now the game is controlled by two fingers on the switch that we can see, and the score is popped up from 10 to 20 because you have hit a ball. Now let us take a full view of the game. You can see the mother PC from which the code was loaded is not needed anymore. When the game is played in the FPGA, the score, you can look at it, the brick hits the ball and the score just popped up from 40 to 50. And in this way you can play the whole game. The player is actually playing pretty well, isn't it? We faced a number of problems while making the game. The very first one, the difficulty in vanishing bricks when they are hit by the ball, and then showing the score. Now how we solved our problems? Instead of defining brick blocks continuously, we defined them in a discrete fashion using limits. When the ball hits a particular brick, its limit shrinks, resulting the block to vanish. The score is shown by the two 7-segment displays. Vanishing each brick block gives the player a big 10 points. About the future development of our game, like every program, this game has room for improvement. 2-layer brick blocks can be defined. The algorithm we developed can be used to build other Pong games too. The speed of the bat and ball and the size of the bricks can easily be controlled from the code, so we can add a number of levels. Before finishing, we'd like to say that due to time constraint and lack of ample working days and complexity of the X-Ball game, the player is deprived of many facilities we could have provided. But we tried our best to make the game enjoyable. Hope you'll enjoy. This project is presented by Abu Saleh Tajin and Syed Muhammad Islam Oil. Thank you all for your patient hearing. Thank you.